So welcome everyone. We are here live with a webinar, and this time we are not doing a very native thing though, but we have a special guest to introduce. We have among ourselves Edmund Kwok. I hope I have not butchered your name, Edmund.
It's okay.
So Edmund, would you please go ahead and introduce yourself?
Yeah, so I'm Edmund. I'm currently based in Malaysia, Kuala Lumpur. So with the time zone, it's 11 o'clock here, 11 p.m., which is good timing. So I'm currently the director of infrastructure at a health tech startup, moving from the startup called the Clinician. And what we do is we build solutions for software for hospitals and doctors to help the patients to measure their outcomes better and at the end be able to provide better healthcare outcomes.
Cool. So Edmund and I have met under different circumstances though, but today Edmund is here to share his industry expertise and knowledge insights with us, and maybe we'll learn about Terraform, GitOps with Terraform. I think that is an awesome topic to share with everyone, and we will learn a lot. So without further ado, I think we can start. If you're okay with that, Edmund?
Yeah, sounds good. Let's see, cool. two admin now. So I wanted to do like a quick a poll on what everybody is familiar with, if everybody is familiar with Terraform or not that familiar with Terraform. It's a small group, so we can just do a quick round. So does everybody know what Terraform is here?
Should I go ahead and maybe break the ice?
Yes.
Yeah, so I understand it's infrastructure as a platform. It provides a provider agnostic deployment system. So we recently had also had a webinar presented by Lobane Rahman. So I think people who previously joined here knows a bit about Terraform, but it's still a lot to explore, and not everyone is utilizing it. And I think it's provided by HashiCorp.
Yeah, so it's a infrastructure as code tool provided by HashiCorp, and yeah, it's cloud agnostic, and it allows you to manage different various types of services and represent them in code. And today, let me start the slides. We will cover Terraform, but having this GitOps in mind when we talk about Terraform. Can I share my screen?
While Edmund does that, I have an announcement. I think Edmund has a job opportunity to share today, later on, after his presentation, maybe. We will get back to that, right? Okay, Edmund, thank you. Please.
I think I need permissions to enable screen sharing.
Yeah, just a second. Hassan, could you look into that?
Just a sec, please.
Yep.
We can do it.
Perfect. All right. Yeah. Let me start the slides. Okay. Right, can everybody see my screen?
Yep.
That's good.
Yeah, so the topic today is GitOps with Terraform. Right, I just wanted to reflect on my own journey of how I ended up in this industry and particularly infrastructure and also DevOps. So back in about 13, 14 years ago when I was doing my undergraduate in psychology, and I had some computer skills, right? And being someone with computer skills, you do end up being approached to help with different things. And one of the things that I was asked to help in with is to build like a platform for the university to enroll students in like a tutorials. So when in a uni system, you've got different tutorials where people sign up depending on the slots that they like and which tutorial that they want to go for. And then that happens at the beginning of the semester. And yeah, being the only developer, building that code, writing that code, and then deploying it in that server, it's straightforward, right? You have it in your local, you build, you package it up, and put it in zip file, and then you upload it to SFTP then, right? FTP, maybe not even SFTP, but just FTP, and then you put it in the server and it's live, right? And you just do that, you make any change, you package it up, you zip it up, you upload, and then you unzip, and then it's live, and any changes is like that. And as I get better at that, instead of using FTP, I built scripts. And it's the same, you just replace this FTP in number 3, step 3 there with a script. And instead of needing to drag and drop things, you just run the script and it gets deployed, right? And of course, then as the code grows, as we talk about maintainability and version control and being able to track what you build and being able to see your mistakes and then learn from them as well, you have this version control systems, right? You start putting your code into a repository. I started putting my code in a repository, and back then it was Bazaar, I believe. So Git was one of the other options together with SVN and Mercurial and Bazaar, and I ended up with Bazaar. I don't remember why, but I used that. And so instead of having everything just on my local on directories, and you save multiple files, you create multiple files when you have new releases and new versions, I put it in a repo. And how do I deploy? Same way, right? It's in the repo, yes, but when I deploy, I put it still in a zip file, I run the script, and it's deployed. And yeah, that worked quite well. I was the only developer then, and things were running smoothly, and the university was happy. And after my time at the uni, I joined a startup. So I did psychology, but I didn't finish. But I did go into tech after that, regardless of what I studied. And then I work in a team, right? It's a tech team where now there's more than 1 people. I can no longer just do things from my local, right? You need to share that code somewhere. And someone else does the deployment. Or maybe it's myself or someone else doing the development, passes it to me, or I do development and I pass it to someone. But the same, right? You've got your repo, you build and you package it, and this time, instead of you uploading or running that file to the script to deploy that zip package, you pass it on to someone, or someone passes it to you, right? Nothing much change, only someone else is in the picture and they do the same thing, right? And of course, we got better at managing deployments, right? Instead of using zip files, we thought, hey, the script on the environment could just pull from that same repository, right? Instead of having a separate zip, why not have the script just pull straight from the repo? And this is quite common, right? I remember our time in one of the early startups or relatively bigger startups, we still do that in the beginning. We SSH into the server and we do git pull and it's deployed. And it works, right? Up to production, multiple customers, thousands and thousands of customers, and it still works, right? And then came Kubernetes. Or even before that, you've got Docker Compose and a Docker Swarm and all those things makes deployment much easier. Instead of a Git, you have a Docker image that you then deploy much more consistently or predictably, or more predictable way of deploying things. And of course, Kubernetes today, it has beat Docker Swarm and Docker Compose in terms of this orchestration platform. And so with Kubernetes, how do we deploy? And there are new elements now. right? You've got this code repository still, right? We still all commit to Git. And now we've got this pipeline, or the CI/CD pipeline, or continuous integration, continuous deployment, delivery. And then this pipeline pushes it to a registry. And this registry is where your Docker containers or Docker images are built, and you push it to a container registry. And then as a developer, you build the code, your pipeline builds the Docker image, and it pushes it to the registry. And then how do you deploy? Someone still triggers that script, right? And instead of the script pulling from Git, the script then pushes the Kubernetes manifest to Kubernetes, and Kubernetes then pulls the image from the registry here, right? So similar, you still have one person, the developer, number one, and then number five, someone who does the deployment, or it could be the same person, but instead of zip files, so instead of pulling from the Git repository, now you have Docker images, right? And still, that's not the end, right? And moving forward into different things and different tools that are now available, you move on to this pattern where you completely eliminate the person who is doing the deployment. That commits and pushes still to the Git repository. You still have your pipeline, right? And then the pipeline, same thing, builds the Docker image and pushes it to the registry. And instead of needing someone to run the deployment script, the build pipeline also, and number three here, updates this config repository. This config repository is another Git repository, but it contains all your infrastructure and deployment related code. So your first repo on the left would just be application. And the second repo here is everything about your infrastructure and your clouds, components, or VMs, etc. And with that, on that config repo, you have another pipeline, and that's the deployment pipeline. And that pipeline itself will do all those deployment with Kubernetes, running the manifest or applying the manifest rather, and Kubernetes will then pull it from the container image. So what's different here is we totally remove this deployment person in the middle, and everything can be done end-to-end from the developer, number one, and everything goes into the respective environment. And this is something that is becoming more popular, or becoming more something more popular. People are looking into this because it is a easier way, or better way, and we'll talk about some of these benefits in a bit. In this way of deployment, I didn't know that there was this term when we were doing it this way, but this term is GitOps. When we were doing it in this way of having one pipeline to build and another pipeline to deploy, and everything is automated, lo and behold, someone coined the term called GitOps. And one of the definitions for GitOps, and which I find makes sense for me too, is this. It's essentially Git as a source of truth for all operations. And when we say all operations, we really mean everything, right? So like I mentioned, in the config repo, you have your infrastructure components. And GitOps is really that. You have application codes, your configuration, your infrastructure as codes, your dashboards, your whatever, everything that you need to deploy, to build and deploy an application to an environment at the end. Everything goes into Git. And that's the Git part of the GitOps. And the ops part is the automation. You have your code, like I said, and you have an automation in the middle. This is the ops part that is automated, and it goes into the runtime environment. And we'll just focus on Kubernetes for today. It could be bare metal where you deploy just a binary or a Docker image, maybe not on Kubernetes, maybe on Nomad or what other orchestration frameworks. But the point is, you have your code in Git and your infrastructure is code, your application code. There's some automation in the middle and that gets deployed at the end. And like I mentioned, this flow, this in GitOps is called push-based deployment. So whatever is deployed is pushed from the config repo to the development pipeline or the deployment pipeline, sorry, and into the respective environment. There is another pattern called pull-based deployment. So instead of the config repo pushing the changes or the deployment to the Kubernetes cluster, in the Kubernetes cluster itself, you have an operator, a Kubernetes operator that essentially just observes that config repo that we talk about and the container image registry as well, that the application is built there, right? And instead of things being pushed to the Kubernetes here, it continues to monitor the registry and the config repo. And anytime there's a change, anytime there's a relevant change that the operator is asked to observe, it will then see, hey, this is a change. There's a change in the container image or this is a change in the config repo. I need to do something about that change because the current state in Kubernetes is different from what this new change is coming. And then I can make a diff of those change and then I can deploy those change. So it's still automated, but instead of it being pushed from the config repo, it's pulled by the operator itself and deployment also happens. Right. Any questions so far from what we have covered?
The audience, you may question me in your native language if you know Bangla. So you can talk to me in Bangla. I will transfer that to Edmund. And if you are good with English, you can just go ahead and type your question or you can even speak. We will continue now. Thank you. Edmund, please.
Shall I continue and we'll just have questions in the background?
You can continue, I think. If
okay.
someone asks any question, I'll let you know.
Sure. So some of the key principles of So some of the key principles are for GitOps are these three. So the entire system infrastructure and application is described declaratively. So declaratively is usually contrasted with imperatively. So declaratively means I represent in the code what the outcome should be. Like I want to have 5 replicas of this application. I want it to be running on port 80. I want it to be available at this subdomain and domain. Versus imperatively, I write scripts to run those deployments, to change the replica, to change the DNS, and etc. So the first principle is everything must be able to be described declaratively instead of imperatively. So we focus on the outputs or the outcomes versus how those things are achieved. And number 2, everything is stored in version control. And in today's case, we will talk about Git, right? Or we focus on Git. And so all system state, including, like I mentioned, all your cloud components, all your DNS records, all your dashboards, all your network level components as well, right? Everything is stored in version control. Nothing should escape. Nothing should be on anybody's local, or nothing should be lurking around somewhere, which is only brought out when there's an issue to resolve or when there's a new deployment, right? Everything goes in version control, and changes to the desired state are automatically applied to the system. So this is the automation bit where we have a pipeline or like an operator within the Kubernetes cluster that will automatically apply the intended changes. With me so far, everybody? Okay, yeah. So one of the key benefits, or some of the key benefits are this, right? Of course, being in Git, everything in Git means it's version control. version control. Yeah, so version control means every change has a history. You can see why a change took place with the commit messages. You can see who did the change. You can see what led to the change. You can roll back, and you can do everything that you've usually done with Git. And this is for infrastructure. And things are automated, right? You get quicker deployment sometimes because you don't have to run all your multiple scripts. You are able to reduce human error. Sometimes deployment can be quite tough. You might go through a long checklist and you might miss a few things. And the speed and efficiency as well when it comes to automation, and everything is self-documented, right? Someone can just go into the config repo and see how all your different components in your infrastructure, in your cloud environment are represented, are composed, are architected. And someone can just go in, someone new can come in and just read through the config repo and be able to figure out, okay, in this environment, I've got this network, this number of VMs, the number of nodes, this number of namespaces, and this is how it's all organized, and etc. Right? Everything is self-documented. And it's auditable as well, right? It's similar to version and auditable. You can track whenever a deployment is made. You can see, okay, who deployed this, when they deploy it, what time they deployed, even, etc. Everything that is version is auditable as well, and you can run through a trace if there's any issues that you need to fall back to or you need to investigate. And that makes things, you can roll things back as well, right? So being things on Git, you can go back to commit, and even infrastructure, you can roll back your infrastructure. And of course, things are also more secure, because now your deployments are run via Git pipelines, or just pipelines in general, and pulling from Git. And instead of an operator needing to run some scripts and have the necessary credentials, production credentials, staging credentials, having somewhere on your local or in some jump host somewhere, the operator only needs to manage the Gits for the config repo. The developer doesn't need any credentials to push things to the environment, and they can just run the pipeline, and the pipeline themselves has all the credentials necessary. So you remove the need to share unnecessary credentials, especially to your production instances and more secure instances. And these are some of the benefits of GitOps. This may not be everything that GitOps will help you with, but these are definitely some of the key ones. So recap, we've got codes, application codes, we've got infrastructure as code, your application repo is one, and then your config repo is separate. So one thing that is proposed to separate your application repo and your infrastructure repo or config repo is that you don't want any change to application repo to trigger a pipe. Okay, if your code repo and your infrastructure repo are together in the same one repository instead of separated, it means that anytime there's a change on your application, that pipeline will still run and your infrastructure may unintentionally be changed. Likewise, maybe you are doing some change in your infrastructure within that same repo, and that pipeline gets run, and then your application may be affected unintentionally as well. So when you separate the application and the config repo, you can manage that pipeline. You can manage when that triggers separate. And there's automation, and we talked about pull-based, push-based, and then all of that goes to runtime environment. In this case, Kubernetes.
Edmund, if I may interrupt,
yes.
There seems to be a lot of people joining, so let me reintroduce here what's happening. So today we have Edmund Kwok with us. He is the Director of Infrastructure at the Clinician, and today he's presenting us with how to do GitOps with Terraform. So yeah, if anyone have any questions, please go ahead and ask me in the chat. And if you are not familiar with English, you want to speak in Hindi, Bangla, or Urdu, you can chat, get the question in the chat. I will transfer that to Edmund. All right. Edmund, please go ahead.
Yeah. Am I too fast, too slow, or is that okay, Faisal, from your perspective?
Well, I'm getting the hang of it. I think people should be fine.
Okay.
Once you maybe you present that architecture diagram a bit more so that people gets more familiar. I think that helps.
Yeah. Okay. So we'll just go straight into demo because it's demo time, right? And maybe the hands-on will be more helpful to see how this all works. Okay.
Sure.
So with the demo, what I want to hope to achieve, right, is to show, to work together to come to this push-based deployment, right? So we'll see if we can do it in half an hour. Okay, so we've got a application. We will figure out how to deploy it and have some pipelines and push it to some repository and have a config repo and that have its own pipeline, and then we push it to a Kubernetes environment. Okay, let's begin. Let me swap over to my code. Oh. Okay, so I've got an empty folder here. And of course, the first thing we will need to do is to have an application to deploy, all right? So let's go ahead and call that app, okay? And for the application, what I've got is a simple node-based application. Let me pull it over from the other source control here. Yeah, so this is just a basic Node.js application that it listens on the port. It's an Express app that is a web application. It listens on the port that we specify here. And when you go to echo, it will just echo back the query string. If you append a query string to echo in the body, there will be a query string that is echoed to the browser. Can you see the code size? Is it okay? Should I increase it a bit more?
Maybe zoom one step more. Yeah, that should be fine.
That's better? Okay.
Yeah, if anyone has any problems with the code size, please mention. Yeah, I think we're good.
Okay, cool. Yeah, so first things first, let's make sure it runs on your local, or on my local, right? Make sure we do npm install. Let's see what packages it needs. Okay, just Express. Oh, that's quite quick. Okay, so yeah, we've got all the necessary dependencies here, and then we run, what is it, server.js. Right, and we go into our browser, and it's listening on port 8080. Oh, yeah. So this is probably, yeah. So this is the echo route, and with the echo route, you can just give it whatever and echo secure, right? So nothing fancy, but just to show you that it's a web application that has a different path which responds to a query string. Okay, so next thing, what do we need to do in a GitOps deployment? We need to make a Docker container or a Docker image. We need to build a Docker image for it to be deployed in Kubernetes, right? Because Kubernetes itself only accepts Docker images as its deployment artifact, okay? So one of the ways I like to build Docker images is use Alpine image. That's the Alpine based image is small, it's lightweight, and I like really small image sizes. And also it's supposed to be a bit more secure. But of course there are issues with Alpine being this whole glib and MUSL, but we won't have to worry about that today because it's just a simple application. So the way I like to build Docker images is to run the base image that I want. So yeah, so H, and then I'm just gonna that here, and yeah, if I go to apps, then I have my so I just want to make sure that this this base image can run the application. Oh, scratch that. So actually I should be going to node. Should have an Alpine image with node pre-installed, which is okay, let's run that again. Okay, that gives me the nodes from interactive, which is not what I want. Shell, okay. Go to app. This runs, right? We know that it's supported in Alpine, all the necessary modules are there. And let's just do that again, but this time that this Docker container works. Let's give it a different thought. Okay, so this one definitely will not work because we're no longer on 8080, but we're about 8000, which is not. Oh. Yeah, this one is the same one that works. Okay, so now we know that this base image is fine. We'll go ahead and create a Docker file on base image. Because the base image is empty, we need to run, first copy the package.json, package log, server, and index file into the Docker container. npmi, which is npm install, and that should be it. We could do start. I'm just gonna add the Docker ignore here. Don't want Docker to pulling the, so I can just do build, give it a name, start for demo. Let's call it E1. So Docker should replicate the steps that we're doing locally and push it out to an image. And then we can try running this for real. What are we on? Okay, so we've got our Docker image. And let's confirm this is port 8001. Okay, perfect. So now we've got this Docker image. This is one step done. Okay, and this is the same Docker image that we want to deploy into the respective environment. So for the environment, I already have a Kubernetes cluster deployed, and of course, being a Terraform session, I've got that deployed with Terraform. Let me just quickly show you that Kubernetes cluster up here. folder. Right, so this is just the Terraform EKS tutorial that you can download or you can clone straight off from HashiCorp's website, I think. I can share the link if you want, but with this, I can just go ahead. Let me just show you. All the different Kubernetes, the Terraform configuration on deploying a full EKS cluster, which is the AWS EKS is the managed Kubernetes offering from AWS. So you've got all your different components here. You've got your network stuff here.
So all these boilerplate codes are available in the Terraform site?
Yes.
All right.
So you can just clone and run it straight away. Show you that. Yeah, so you can read all of those or explore all of those separately. We don't really need to go through the EKS part today. But let me try and run this and see if we can. So with Terraform, we just need to do Terraform apply. Right, it's a quite a big Terraform config, but it's going to query the state file. So Terraform saves the previous deployment into a state file so it can compare what's new or what changed or what didn't change or what needs to be added or removed. And this is what it's trying to do now. Sure, we already have a state. I might have an existing state that it's trying to. Right, so I've got already one cluster here deployed, but let's try something else. Let me change this to EKS tree. See. Put an existing state here. Move that to the trash. Okay, I'm going to initialize the backend first and get Terraform to download all the necessary provider modules. And we can run Terraform. Should give us a cluster that can be. Do the same thing with the state file, and we've got 54 things to add because this is a fresh cluster. So you see in AWS, you've got all your VPC subnets, public, private, and your NAT, your internet gateway, and then etc. Right? Let's go ahead and run this. And we don't need to worry about this because I've got a cluster set up, but just to show you that this is all in Terraform, and this is all, like we mentioned, everything that you need for your infrastructure should be, can be, must be in Git for GitOps to work well, right? So it should spin up something here. But while we wait for that, let's go back to where we were. So we wanted to.
So a question to Edmund,
yes.
if I may. So are you using Omizishal?
Yes, I am. Yes, okay. I am.
So, and then another question for me would be that where is your Amazon configuration, AWS configuration set up here?
Where meaning is the credentials or?
Yeah, the credentials. Yeah.
Yeah. So the credentials.
Yeah, please go.
I'm sorry, go ahead. The last point I missed out your last.
So where are your AWS credentials hosted currently?
Right. Yeah, so currently it's the local. The typical AWS config file, you've got your profile name, your access key, and your secret key. So I won't open this file because it's lots of access key, but this is just standard AWS config. No, thank you, Iman. No tricks here. So Terraform will just take from the default credentials provider. In this case, it will be the IAM config keys that is native to AWS. You can even pass in environmental variables, or yeah, there's many ways, but this is just default. Yeah, and is a cluster coming up yet? Yeah, so we have this cluster. This is a new Kubernetes cluster. I don't think you'll wait for it, maybe 15 minutes. It takes about 15 minutes to provision. So we'll come back to the application. Right, we've got a Docker image. Now we want to put that into a cluster, right? In, like we mentioned, we want to have a separate config repo, right? And of course, we'll use Terraform. Yeah. So Terraform, as you know, you have your main Terraform config file, and I'm just going to copy a existing deploy manifest or Kubernetes manifest from Terraform, right? Let me see here. Okay. So I've got a Docker registry, and we'll come to that in a bit. And the way that I've set up this config repository is to pull the Kubernetes or kubeconfig from the existing cluster or the cluster that we are currently deploying. So it pulls the remote state from the other EKS Terraform config. So the EKS itself is a separate config. Terraform config, a separate repo. You've got your config repo for your application, and then you've got application repo, right? So now this config repo, you can use Terraform remote state to just pull in the EKS state file, and the thing that we're interested in there is this kubeconfig outputs, or this kubeconfig value, which is essentially everything that you need to access your Kubernetes cluster. And with that, I can just run this and I can access the cluster. What else is interesting here? I've got some secrets. So with Kubernetes, of course, the Kubernetes runtime itself also needs access to that Docker registry. And today I'm using this GitLab registry. And you may know that it's using the way that you add this credential for Kubernetes to pull from one or more Docker registries using this secret that is a Docker config JSON. And yeah, this is all common or just standard Kubernetes secret for Docker registry credentials. Deployment, right? So we're using Kubernetes deployment here. And of course, you've got your metadata, which namespace, how many replicas. These are all Kubernetes manifests, but represented in Terraform. And the main thing we want to change, or the main thing that is important, or the important thing for the deployment, is a Docker image, right? And here I've got a image and tagged by the commit hash. So we've not gone into any of that yet, because we first need to push our local Docker image to a repository, right? So Kubernetes, unfortunately, can't pull from my local, right? I need to push it to a repository that it can access. So let's go ahead and create that repository. I've got GitLab. You can use GitHub, whatever Git, wherever it's hosted. Let me see, I need to create a new project, right? Blank, let's call it Cloud Pro demo app, right? Got repo here. instead of, before I push things to the application code to Git, I just want to make use of GitLab's repository that they provide for free, I think. Yeah. So I can just this. So I already got my image from before. I want to tag this to a registry here. Say docker tag this. Let's call it v1. Okay. And now I can push this. Okay, so I've already pre-login. It's a private registry, so whatever using, you can use Docker Hub, or if it's a private IP code, then whatever private registry that you're using, make sure you're authenticated, you push it. And let's see, we've got an image here, but let me tag it separate. I think that's fine. Yeah. So now we've got this in a Docker registry. Kubernetes should be able to pull this one, right? And we can use Terraform for that. So let's hard code this for now. Okay. I've already got my registry passwords. Let me see. It's my registry password. So I've defined variables here. Let's just hard code things for now. Okay, I've got my registry password. Can pull that out. GitLab and pull it out. Some variables here. Okay. Yeah, so that's the registry password. This is a personal access token that GitLab has, right? And with that, I can, the reason I have this here is I want to put that in the Kubernetes cluster as a credential for it to access the image. Let's see, what else do we need to change? My local config here. Let's put it into a namespace, right? So we will have a separate namespace for this. I put a local variable here. The other variable should point to this namespace. So I'm missing. Okay, I think we're quite happy with that. So one thing that we have here as well is a Kubernetes Ingress so that we can access the application that we're about to deploy publicly, right? And with that, I'm using Cloudflare. So I'm just showing that with Terraform, you can use a different DNS provider depending on what provider Cloudflare Terraform has, and it's got quite a big bunch of community contributed providers for DNS management as well. And for me, I'm using Cloudflare, and we want to create this Kubernetes Ingress, and this has the AWS application load balancer built in. So anytime you create a Kubernetes Ingress, the AWS controller, load balancer controller would create a corresponding ALB record, and then you can access your service with the ALB record, and for that we're using a CNAME to map that. So let's see, I've got the subdomains here as well. Now we run it and see what happens. Okay. This is the config repo. And for Cloudflare, you need you need to tell Terraform where to find this Cloudflare module, which is that file. Okay. I'm telling Terraform that please take this Cloudflare module from this namespace and project name. Okay. I'll run plan first. Let's see what I have. So it needs an API token, which I will put here as well. Okay, API token, which is what will be used by here. Okay. The variables and we'll just hard code things first. So access token, this is the API token from Cloudflare, right? Let's see. Okay, it's requesting the commit SHA and just make it a default. So okay. Okay, so now it's telling me that 7 things to change and it's going to create this Kubernetes deployment. All right. Okay, and the Cloudflare records as well. Yeah.
So this is like a dry run?
Yeah, so with Terraform Clan, it just shows you what it will do, and you can save that output. And when you run apply, you can apply this output to make sure that Terraform applies exactly what your dry run has, what you have seen from your dry run. So let's try that. So this is a Kubernetes management tool called K9S. So instead of K8S, it's K9S. So it's like a UI for Kubernetes. So let's go ahead and see that. So you can see BACP demo is being created, right? Let's see if I can split the screen. So Terraform is going ahead and querying or applying the manifest on Kubernetes. It has a state file to check what is new, what is changed. If it's new, do it. If it's not new, make something, change it. And now, so this is a new namespace. We've got our deployment running here, right? And the logs, yeah, okay. So with the DNS that we've specified, we should see this local subdomain, which is BACP demo, right? And it's a CNAME for this domain here, right? So let's go ahead and see if that works. Ta-da! Yeah, it works. So you've got your DNS change done by Terraform, and this points to the Ingress. Actually, no, this points to the ALB, or the application load balancer by AWS, and that points to the respective node on Kubernetes, and then yeah, it reaches your the application. Right? So yeah, this works nicely. Right, and let's do some local deployments, right? Just to see how that changes. So for example, let's change this to not much here. Right, and we've got this change here. So now we will build that image, right? Let's call that. So change here. Build this. Somewhere else. Okay. So I need to tag it to the registry. Right? So I call it V2. So now we should have another V2 here. We'll push that too. And while that's going, we need to change this manifest 2.2 V2, right? Let's go into so now that this is in registry, we can just do a dry run and see what will change. So again, it's inspecting the state, and the only change is V1 to V2, right? Now we apply. See if we can see this changing in real time. Okay, so I confirm that I want to do that. And let's see this change here. Maybe I should go back. Yeah, this is the right one. So this is the old one. This is the new one. And you open it and we can see V2, right? It should be the same URL. Aha, yeah. So that's local based deployment still, right? But with Terraform, with Docker images, and now we want to make everything automated, or we push it to a Git repository and then let Git do the work, right? I am cautious that we are already 1 hour in the time. What's the typical arrangement for that?
It's
Can
all
I
right if you
continue?
can continue that. Yeah, that's fine.
Okay, cool. Let's double time. So we've got this in local, and we want to push it to Git. So the first thing I like to do is to make this build stage, or this build Docker image step into a pipeline, right? So instead of building the image locally, I build it in the GitLab CI, okay? So with GitLab CI, what we usually add is a GitLab CI YAML file, right? So I've already got one, of course, ready. So I've got a build stage here, and essentially this build state just says, use this Docker image. I want to do Docker in Docker because I'm running this pipeline of this job in Docker, and I'm using Docker to build the application image, and I want to push it back to a Docker repository. And so I need to put the Docker file, or I need to build from a Docker file, and this one I've made it into a Docker folder. So in the interest of making things work, I'll just put that into a Docker folder. And you can see here, let's just go through quickly. So I make this tag variable point to this registry image variable, which is a default in GitLab. So with all GitLab jobs, there are some predefined variables, and this one essentially is the GitLab registry URL, right? And what I like to do is to tag this image with the short SHA, so the commit SHA of the image, so I can always know what Docker image and point it back to a commit SHA, right? And this is logging into the registry, building it, and pushing it. Okay, so let's push that and see how that goes. So not a repository yet. Git init, and I want to add a remote. All right, and push, and it'll tell me to set up upstream.
Yeah.
So node module there. Git ignore it. Sorry?
No, it's okay.
Okay, make sure I don't commit unnecessary images which we got a predefined npm or nodes base git ignore. Okay. Yeah, that looks about right. Okay. So initial commit. Oh. Now when that's pushed, Docker, okay, GitLab should tell me that I've got a pipeline already here, right? So this pipeline, it's using GitLab's shared runner. So out of the box, I think GitLab gives you few 100 hours for free, and you can run your jobs to that, or you can run your own GitLab runners or self-hosted and then not worry about the hours to use. So it's going to pull the base image that the job will be running in. It's going to start the Docker service for Docker and Docker, and it's did that same Docker build that we did locally, but in the CI, and it's pushed it to now this Docker image path and tag. Okay, so with this now that's in the public, it's already public, right? We've demonstrated that it works locally, but now we don't have to do the job of building it manually. Everything can be done through GitLab. Okay, so we're done with this. Now let's move to the config repo. So we want to put the config repo in Git as well, so we can match them up, right? So just to show you a quick one here, like we'll make a change here, and this is just one half of the GitOps side of things. Update index from wait for the pipeline to finish. Just to show that this is one side of the, having this itself is a big step towards building Docker containers with your pipelines, because once you have the Docker containers or Docker images, rather than you can deploy anywhere that Docker can be run. Of course, building Docker images is a whole different session altogether. But with Docker containers, Docker images, you are pretty much able to run your application without worrying about dependencies and runtimes and etc. Right, so let's take that one just to solidify our understanding. Okay, now it's got a hash instead of just v1, v2. Try again. Okay, we can confirm that it's just changing. Working. Right, this is the new container. Yeah. It's not ready yet. It's going to be ready. Yeah. And once it's ready, we can refresh the page. Let's give it a moment. Now, what happened here? There we go. It just needs some time to update ALB, I suppose. So yeah, this is the one that we built here, right? You've got your codes, you've got it built as Docker image, and right, this is the same one, right? And now instead of doing Terraform apply locally, we want to do it. We want to have this in a GitLab CI job or whatever CI they're using. So same way, we need to create a GitLab CI to go ahead and create a repository for that. Let's call it EACP. Okay. So what do we put here? We want to put, let me pull up the chart that I have. So let me first make sure I've got the right stages. Build, deploy, verify, and we're using a Docker image with AWS Terraform, AWS CLI and Terraform already pre-built. Right, I've already built that beforehand. There's a before script that I run. So like we did Terraform init initially. There's this other stuff here that we don't need right now. So before we run anything, we run Terraform init because the runners are all new environments. It will not have the cache and all the Terraform providers already installed. So we run Terraform init all the time and we put input false because we're not expecting to be able to respond to Terraform. And the same way we put auto approve. And what we're doing here is say, hey, build this kubeconfig file within the GitLab CI runtime. And we do Terraform apply, right? And it's just go ahead and pull the same config they're running, but in Git, right? Let's see how that works. So some Terraform here files that I also want to ignore. Okay, it looks much cleaner. So git add, and then so one thing I didn't do, Right. So one thing I didn't do was actually specifying a state for Terraform when I push this here. So let's see what happens. I might break something. So because when we're doing this locally, right, all the state is in our local, which makes sense if you are just doing this on your own. But as we said, things goes into a Git repository, and this state contains sensitive information like credentials and your kube config and different API tokens and etc., which as a principle, you should not commit state files which may have secrets, or you shouldn't commit secrets at all, right? So what we would do is you have your Terraform remote states, and essentially, instead of it being on your local, the state file is either in one of those supported backends, which is S3 or console, or it's a few bunch. And for Git, we need to specify a state. So what's going on here is I've not set up my AWS credentials, and I will do that in a bit. So to do that in GitLab, I will put that into a CI variable here and have the credentials here. Yeah, let me do that in a bit. So let's go ahead and add that state first, just in case. I want to say using S3, and this is the buckets and be a Cloud Pro demo. Okay. Should that. Push that. Still going to complain about credentials. Let me do the credentials on a separate screen, right? So you can't peek. Okay. So I'm just going to use the default IAM variables here. Okay. Just bear with me. All right. So you see, I've added AWS access key ID and AWS secret access key, right? So those are standard IAM variables. And once we have that in, we can trigger this and see what happens. Okay, it's gonna do the same thing as previously. It's gonna pull the Docker image that the job will be running in. In this case, it will be this AWS CLI, which let me just show you. It's just a simple Alpine-based thing. Here. So it's a Terraform Docker image, and this is running on Alpine. So I just use it to install AWS CLI, JQ, which is a JavaScript, JSON querying utility, curl, of course, and curl to download this AWS IAM Authenticator, which is used by kubeconfig. So the way AWS does Kubernetes authentication is using this AWS IAM Authenticator application or CLI, which queries the Kubernetes backend and based on your IAM tokens, then allows you to connect to the Kubernetes cluster, right? So these are all prerequisites to for the job to succeed. Okay, so it's telling me that the namespace already exists. So this is based on the Terraform state file. So the state file, as you remember, it's empty in GitLab because it's all on our local, right? And Terraform doesn't know that there's already a namespace that we've deployed locally, and it's complaining that, hey, I'm not gonna be able to create this namespace that you asked for because it's already exists. So what we need to do is run Terraform init again. And it should prompt us to copy this backend from our local to S3. Right? So this same local state file that we have, Terraform has deleted it and put it into this bucket here. Yeah. We go ahead, rerun this. There shouldn't be any change. Okay, so let's just wait. Any questions while we wait?
Well, I guess I can have one.
Mhm.
But you mentioned about the Git difference, checking the Git diff, right? So where is that happening and how is that happening? Could you please elaborate on that, maybe?
Git diff for which one, Faisal?
Yeah, so if you are deploying a new instance, does it do a Git comparison from the previous instance and then do the deployment, or does it?
Yes, so
So
Terraform has this way of, it represents everything that is currently in a deployment in its state file. So everything that we deploy goes into this Terraform state. It's a JSON, and then when you run Terraform plan or Terraform apply, it queries the state of the environment and compares that against the state that it has on its state file. Then with that, it decides, should I deploy, not deploy, should I delete, should I update, or should I create a new components?
so it compares the hash of Terraform state rather than the Git state?
Yes, so it's not using Git at all for comparison. Terraform has its own algorithm to compare the state of the infrastructure versus the state of the current infrastructure versus the intended infrastructure. Yeah.
Okay.
Does that make sense?
Yeah, thanks.
Yeah. So we'll go into Git comparisons, Git diffs in a bit. Yeah, so as expected, there's no change. Terraform is able to query the Kubernetes cluster and able to read the state file and say, hey, there's no change to infrastructure, well and good. So what we want to do now is to somewhat join these two application and commit and config repo separately first to make sure that works. Then we will end with combining both of it. So I'm going to go ahead and that, right. Push that over. For build. It should give me a hash. So it will tag the image with this hash. So while we wait, let's update this hash here. Not yet. So Terraform. Yeah. Okay. We can just commit that first, but not push it. Or make sure that image is built. Right, it's at the same one. We push. Now, instead of running Terraform apply locally, we just click the button here. So we should expect that there'll be some change this time because we changed this hash here, right? And should we open? See. It's taking some time just to pull the base image here. Oh, yeah, so let's get it here. I think the log is delayed. This is a new container. Let's see. Okay, this is 466. Yeah. Asano, what is an acceptable Docker image size for node-based apps? It's up to the respective operator or the respective infra person or DevOps person. For me personally, I like small images because it's much quicker to pull when you do a deployment. But there's no small size or acceptable size. Some images goes up to 2 gigs or 4 gigs or 5 gigs, and that's fine as well. So it's entirely up to the team on how application is complex and you can't run away from a big image. And at the same time, there are some Docker tweaks or Docker tips to produce smaller images, and it's entirely up to each team on how they want to approach that. Yeah? And you might just do zero optimization in your Docker image sizes or your Docker image sizes and benefit from the caching of the Docker layers itself. And that's fine for some teams. And if it's not fine for your team, it really depends. Yeah. So this is done, and we should see this is running, right? And now, aha! So we didn't do Terraform apply locally. We click the button and it's deployed, right? So well and good. So we have manual. Okay, we don't have manual. We have a Git application code building Docker image. We change the deployment hash in the config repo for the Kubernetes deployment manifest manually, and then we click the button to deploy. Right. So of course we talk about automation, right? And we want to automate everything end to end. And the missing link is this way to get this config this app repo to then make a commit on behalf of us, right? And change that hash. Then we have end-to-end automation. So let me just pull that job for that. So this job is a bit more complicated. This is not the only way to do it, but this is one way that we are using. And essentially this job just says, okay, get the current commit chunk, get the current branch name, and that's only relevant if you do branch-based deployments. I need to represent I need to get the Terraform variable file here, and I need to update the commit SHA, right? Actually, I pull the repo, which should be a different repo here. I pull the commit repo, and for us, it would be this repo here. I need to set up the correct token for that. Check out the branch. Let's skip the checkout. And I'm using JQ to change the commit SHA here because it might be an existing JSON file or JSON variable file, and we just want to replace that intelligently with JQ. Commit that and push, and the whole pipeline should run, right? So before we do that, we need to, instead of hard coding the configs here, right? We need to make this a variable with Terraform. Define your variables here, right? In a separate variable file or within the same main.tf, but you have a variable string here. And make that default, and we can pass that variable in to the manifest here. then the way that we decide to pass this in for our purpose is to a df file in JSON. So it accepts JSON and it also accepts HCL, which is the HashiCorp language. Always focus for now, right? So I need to commit those changes to the commit repo. See my changes. Okay, make sure it's commit SHA, status, and get my variable file. Oops. Yeah. Okay. Push that across. And this is the same variable file that we're changing here. Right, let's just make sure we have everything that we need. You're a master. Cool. So I'll push this new job. This is just a container image that has just these two things. Show that container image before we close. So it's just Alpine installing Git in JQ. That's it, right? And we're using that because we're using Git in JQ. Yeah. Okay. Push that in. Actually, let's make a change to the index. If not, see that deploy change. My best commit messages, but hey. Okay, so now you see a new job here, which is deployed. So it's going to do the same Docker image build stage. Takes about 30 seconds, right? And then you see this deploy stage coming together. It's just right here. Okay, now the deploy job is running. Oh, I forgot to set up the token. Tokens here. Yeah, let me set that up separately in a separate screen. Okay, got a variable set up here. Yeah, it's just another personal access token. This should fail, right? Because I didn't have a token. But if I retry, so this is the last bit. Once this is completed, then we have GitOps, or at least push-based GitOps. Okay, it's failed again. Let's see. right repo here. Let's see. I put it in the wrong repo. So I added it to the config repo instead of the app repo. Okay, here. This. Okay, I've got the wrong directory here. Okay, let's see if I can check everything. This work. Wait. Okay. Good job. Should start more. So look at the okay. Now just press play. See what changes it made while we're here. So with that deploy job here, we got it to update the Terraform variable file here. And because we've made that a variable in the Terraform Kubernetes manifest, then it should pull that image for the deployment, which we might see here. Yeah, it's running some, I think it's have any health checks, but it's running its initialization stage. It's not ready yet. It's there. Yeah, we see Terraform is still in the midst of modifying. It's ready. And it's there. We've got end-to-end GitOps, right? And that's the end of the demo proper. And I just want to quickly show you and just recap possibilities, right? So you could do like a different stage. You've got like a plan stage before you actually do your apply. So you can make sure that all this, that you're happy with what's going on in the change before you actually click the apply. And with some approaches, what they do is they put that plan into a merge request. So you can actually, before you accept a merge request, confirm that there are some reports, a Terraform report that, okay, these are the different resources that will change. And maybe this number becomes 5 or 5 is deleted, and then you quickly get alerted, hey, this change is not supposed to delete stuff, and you can just view a log of that Terraform plan. And then you have this merge request-based deployment pattern. So you don't need to, you have another control in place where you create a merge request before you deploy, and then someone with higher privileges can then accept that merge request and put it to the respective environment. And yeah, with that, you can do branch-based deployment or feature branch-based deployment. Every feature branch that you push as a developer to Git repo, you have your own deployment that you can test and play around with your own staging or QA environment based on that branch. Because you use variables for the domain name or the subdomain name, you can have multiple individual branches for all, or multiple deployments for every branch that you have, and you can delete them, or you merge the branch and you can run a pipeline to remove those instances as well. So because everything is in Git, everything feels familiar. You have some helper scripts in between, right? And all those things, there are different ways to do that. And this is just one way, right? Let me swap this over. Yeah, so push-based deployment, you push that into the repo, the application repo here, it goes to the build pipeline, that build pipeline pushes it to container, and the config repo then pushes the deployment pipeline through, and that gets deployed with Terraform on the respective environment. Okay, any questions?
Pretty awesome. That's what I have to say for first. I think we have learned a lot today, and a better understanding of Terraform, that is, and GitOps. It's something new and to explore. I think people are going to enjoy doing GitOps much more. I think I have some questions. So Minhazul has some questions.
Yes, please.
Go ahead. Minhazul, if you want, you can unmute yourself and go ahead.
Yep, sure. Hi, Edmund. How are you doing?
Hi.
So
good.
myself Minhaz from Imani.
Yes. Yes.
So nice to see you for the first time. Okay.
Yes.
So I have several questions. I'll try to make them shorter. So first thing is, what are the downsides if we put the infrastructure files and the code base in the same repo? I mean, currently you're using one repo for the code base and another one for the config.
Yes.
So why you prefer like this?
Do you want me to answer that first or go through the questions? And
This is my first question. So
yeah, so it's a matter of design philosophy, and you may put both into one repo. What I find, or what some people have said, is if you have both your application repo and your config repo or infrastructure as code in the same repo, so your application code and infrastructure code in the same repo, then your pipeline gets a bit messy. So when you change your application code, then your infra pipeline might also run unless you do some crazy logic to differentiate the change. In the same way, your infrastructure code change, then your application pipeline might run, and it might have unintended consequences. So it's cleaner and it's more maintainable if you separate it. But if you have some good way to manage them in one repo, by all means, it's not a hard and fast rule.
Understand. Great. So my second question is, I really like Terraform because I have to manage lots of Kubernetes clusters and applications. So I do not want to use Helm. I don't like it. Okay.
Okay.
So I either have to use Terraform or I have to manage the raw YAML files. So imagine I already have an existing project with hundreds of YAML files. So what is the easiest way to use Terraform? And how can I convert these resources to Terraform native files? Yeah,
I've not come across that problem before, so I can't give you a good answer of this from my experience. But I imagine there might be some open source tools out there that allows you to convert your YAML Kubernetes manifest to Terraform. And there's this new Terraform Kubernetes alpha provider. So it's a bit more native to manage Kubernetes manifests, CRDs and whatnot, but I'm not sure if that's more just a CRD versus a YAML that you can easily plug into your Terraform config. So I wouldn't know the answer right now. Yeah.
Okay, that's good. Thank you for this suggesting. I'll take a look at that. And the final question is it's about templating. So we use Customize to template our YML files. So I think one of the downsides of using Customize is you cannot substitute variables with environmental files, which Terraform can. Terraform has great support for variables.
Yes.
But Customize do not have that. So I have to manually use sed or something else to replace the variables.
Understand.
So this is one of the reason I want to use Terraform. But the problem is, let's say I want to make some changes to the infrastructure files. It's not the cluster image. Maybe I want to add some new environments or some resource limit. So how can Terraform know what is the current image that is running in the cluster and do not alter it? Because I mean, how can Terraform store the state of the deployment?
So an existing deployment that you have or existing Kubernetes resource, you want to have that in Terraform and then just manage that setting for that deployment. I believe with Kubernetes Terraform provider, you can import the Kubernetes deployment. So let's quickly look at that. So Kubernetes deployment, you should be able to run this import at the bottom. Usually all this import are at the bottom.
So I can get the current state of the deployments and import variables from that?
Exactly, yes.
Okay. That's great.
So it's importing the current resource in your cluster, then Terraform converts that to a state, and then you make sure to have that same config definition in your Terraform file, then you can start changing the variables. So most resources you can import with Terraform, even AWS and clouds. Flare,
so I can move away from Customize and start using Terraform right away.
So I can understand Customize. There's this nice way of layering your YAML files, and that's quite nice for some people. So your mileage may vary, right? Unless you find a good way to so what you could probably do is use one of the resources where you compile your customized YAML and put that as an input for Terraform, and then you still run so you get a best of both worlds, maybe for the more complicated things. That could work as well. But I'm not sure exactly which provider or resource allows you to use raw YAML. Maybe there will be some hacks to do.
Maybe I can start Terraform for newer projects, so we can write the YMLs using Terraform from the beginning, so there is no legacy thing. Okay, so
that's one way.
Thank you so much, Edmund, for your time and all the suggestions you did throughout the session. Thank you.
Thank you for being here. Appreciate that.
So speaking of starting for a starting point, so Zial is asking, what is the best way to learn Terraform?
HashiCorp, HashiCorp tutorials are really good. So HashiCorp has really good, let's see, let's go to Terraform. They've got really good tutorials. Actually, their guides are really good. Let's see. Yeah, so their documentations are very solid. A lot of things that you want to learn from ground up to advanced that you can find all on their website. I'm just trying to look for that guides that Terraform usually has quite nicely. Yeah, I can share the link later when I find it, but
Could you post it in the chat maybe?
yeah, let me see. Okay, yeah, this is more familiar. Post that in the chat. Yeah, so they've got really good, they write really good tutorials. You can just follow everything end to end and even all the way to, yeah, building, changing, destroying remote states, outputs, and yeah, all the deeper topics about loops and looping through your code and having defining your IP subnets through Terraform functions. All those are, I'm sure, covered in these tutorials. Hope that helps.
All right. So I do have a question about the images that we have been deploying. So what happens with the older images since we replace that with the newer deployments? Do we get an auto deletion or something in the Terraform, or do we have to like manually delete or delete?
Yeah, so Terraform, because that is the image that is pushed to the container registry, Terraform doesn't perform any maintenance on the registry itself. So the maintenance of the registry depends really on the registry provider. For like GitLab, I think they've got a feature to expire images. So you can set like, oh, anything above 3 months automatically gets deleted, or you can run your own housekeeping script that deletes all images from matching this tag or matching this commit hash. So Terraform doesn't manage that for you. Yeah,
okay. So
you have to do that separately.
So imagine I'm doing the same thing with GitHub and using AWS as a container registry. So so that's also possible, but we have to do the housekeeping stuff manually, right?
Yes, you probably do that housekeeping separately. I'm not sure. I think AWS Container Registry also has a housekeeping function, but if not, you could write a script that every 7 days or every month just prune images that you don't use.
Right. Cool. Okay. So another question: how stable is Terraform platform, and are you using it in production? If yes, recently I have read an article where it says Airbnb deploys 150,000 times a year. So we all want to move from development to production environment as soon as possible. So what's the schedule or the recurring event that we can deploy from new requirements to production?
As fast as your pipeline. As fast as your pipeline. So for us at the Clinician, code to deployment is about an hour or an hour and a half. And so we could do technically at least 20 deployments a day. So, because we've got everything in the pipeline, we just click the button. So yeah, it's as fast as your pipeline and you can reach that scale of Airbnb and whatnot. Yeah, so it is possible where everything is automated.
Does that actually happen in the real world scenario, or is it just theory? Okay.
Yeah, it depends on how you manage your release cycles. Like for us, we manage it based on when a customer request comes in, and then the development team works on it and it's ready for testing. Then they can just deploy it when it's pushed to the respective branch. In some places, maybe they want to just release every hour and have like canary deployments and just split their traffic 20% to this new canary deployment and run some a real world test on it before they swap traffic over. So it can be as frequent as long as you want. And the point is, if you have it in a pipeline, you don't have to worry about all the manual steps and your checklist and forgetting things. And it's just there, you know, you can deploy it in one click. You can worry less about deployment itself and focus your time more on the stuff that can't be automated, like actually building the code. Yeah, I'm actually building a great product.
Yeah. Thanks so much. So if anyone has any more questions, we can go ahead and ask it now, or else I think Edmund has a announcement to make.
Yeah, so just a single slide, right? So on behalf of the dev team, really. So I am part of the engineering tech team, and my team is the infrastructure team, and we work very closely with the dev team. And like you see, the dev team are mainly worrying about the application repo. And for us, we worry about the deployment or config or the infrastructure repo. But of course, as we're growing, we're continuously needing more help to build the product and for different customers all across the world. And we are really looking for a senior backend engineer, particularly with Node, experience with Node and cloud native stack, and particularly AWS. And the options, this is just an overview of the technology that we use. Some are deprecated, so Linode and DigitalOcean and Voucher. We're sticking to AWS for now. Docker machine, we are deprecating, of course. Yeah, so everything you see here is what we use in production. And yeah, we use technology that fits the purpose, not just buzzwords just because, but really because it fits the features that we need. So the backend team really needs help to build more products and send it our way that we can deploy it. And the position is remote first. The tech team is remote first, and you can work from wherever you are. Because of the COVID situation and lockdown, we did mention something about migrating or relocating to New Zealand or Singapore is an option. Of course, for the right candidate, that can be an option, but it's a bit later now because of the COVID situation. But if you're wherever you are, if you are interested to help us do what we do, get in touch, and yeah, let's have a chat. And yeah, you can work from wherever you are, and we're quite happy to speak to you. Yeah.
All right, great news. So is it okay if people drops their contact and stuff to be a Cloud Pro and we contact?
Yeah, all good. Do whatever process works for you. Yeah.
All right, so I will drop in the Gmail here, Cloud Pro. This is the simplest email we can have for now. You can drop your, sorry, I think I missed the pro. Let me try again, the Cloud Pro @gmail.com. So you can drop in your CVs or resumes here. We will share that with Edmund. And if you want to get in touch, I'll let him know. Yeah, so I think we're pretty close to the end of the session. It's been a longer one than we expected, but
yeah,
it's pretty good.
Sorry, me too.
I hope it's not very late and you're still good to go.
Still okay. I still can understand questions and answer questions, so I'm okay. Thank you for bearing with me.
Yeah. So thank you, Edmund. Hope to join you for another session maybe someday. And if you have anything to ask you, we will forward that to you.
Yes, please. And anytime and ask and I can respond email, or we can have a chat too. Calls or whatnot. Yeah, happy to exchange ideas.
Yeah, sure. So I think we're gonna close the session now. So if this session will be available in YouTube later on, and you can watch them later. We will also send you an email if when the video is uploaded and ready to share. Stay with us. I think we are good. Thank you, Edmund, again. We can close the session.
Thank you, Faisal. Yeah.
Right.
See you all. Have a good day. Bye-bye.